The first ever data centers were known as mainframes. These were very complex and secret facilities designed to inform military intelligence during the 1940s. Computational technology surged throughout the 1960s, eventually enabling NASA to complete the first moon landing in 1969. The arrival of personal computing in the 1980s marked the dawn of data-driven technology. Higher volumes of people began to interface with servers located within data centers around the world using the internet, laying the groundwork for the modern mission-critical facility. The dot-com era of the late 1990s witnessed a wholesale reshuffling of world economies brought by the rise of the internet, consequently marking the boom of data centers worldwide, which would subsequently in time prove critical for national security, internet infrastructure, and economic output. Throughout the 21st century, organizations have sought rapid internet connectivity and non-stop operation at an unprecedented scale. Designing and delivering elaborate data centers and internet infrastructure has not been a viable solution for many smaller organizations. Thus, multinational corporations have developed vast facilities providing an array of services and technological solutions. At present, an astounding 85% of the world's population owns a smartphone. The widespread adoption of this technology illustrates our constant engagement with data. The global volume of data produced has grown 74-fold from 2010 to 2023, reaching 120 zettabytes and is projected to hit 180 zettabytes by next year, 2025.
Over the past 2 decades, global data consumption has surged at an unprecedented rate. With the continued rise of streaming services, social media, remote work, and connected IoT devices, data usage is expected to grow up to 20% annually for the foreseeable future. As artificial intelligence and machine learning technologies expand exponentially, this trend shows no signs of slowing down.
The amount of data center supply under construction in North America's top markets increased by 70% compared to a year ago to a record 3.9 gigawatts.
To support this rapid expansion, we must focus on developing more energy-efficient hardware, advanced cooling systems, and smarter power management technologies, while also exploring alternative power generation options.
In my opinion, we have seen the recent push in the data center industry to embrace adaptive reuse of existing commercial and industrial sites. This is being perpetuated by several drivers in the market. First, the increased demands for power and site turnover for AI training are outpacing the ability to deliver new greenfield sites and secure new resource capacity for these sites.
I think nuclear could play a role through SMRs, which should be commercially viable by the mid-2030s. There's been an increase in the development of large energy storage systems to support renewable energy, and a reduction in fossil fuels in favor of more sustainable biofuels or green hydrogen. One certainty is that these will require massive infrastructure improvements. This is a big challenge for the engineering community, but a great opportunity for HDR to help our clients navigate this complex transition.
Forecasts suggest that data center capacity in the APAC region will grow at a compound annual average of almost 20% through to 2028.
The future data center will be a more agile, more sustainable, and more technically versatile entity, able to balance AI's growing demands with the urgent need for carbon efficiency. At HDR, our interdisciplinary expertise allows us to provide clients with resilient, forward-thinking data center solutions that meet today's demands while anticipating tomorrow's needs. And for me, that's where we can really make a difference to this industry.
The data center industry in Europe faces a significant supply and demand imbalance. In 2023, there was a take-up of 601 megawatts across Europe's largest markets, compared to only 561 megawatts of new stock.
We have to look at how we increase the power to individual sites. We have to look at how power is delivered to individual racks. We're now looking at 220 kilowatt racks. We have to look at new busbar systems. We have to look at how we can move transformers closer to the racks or pods of AI equipment.
As someone raised in the Silicon Valley of the UK, I've had first-hand experience of how data centres can positively impact a town like mine. These facilities produce high-paying jobs, partnerships with local governments, educational institutions and businesses. For every job created in the data centre sector, an additional 1.5 to 3 jobs are produced in the wider economy.
Additionally, due to the power and water requirements of data centres, the investment can have spillover effects by improving the resilience and efficiency of local utility services. This may lead to more stable power and a better utility infrastructure for the community. Moving forward, many data centres are being built with commitments to renewable energy sources. When this is partnered with local renewable energy providers such as wind or solar farms, this can drive demand for clean energy infrastructure, which can benefit the entire community and reduce overall carbon emissions.
Data centres are fast becoming the backbone of our digital society. As we rethink a net zero future, our industry has to be increasingly circular, modular, and sustainable in the design and delivery of energy-intensive infrastructure for the 21st century.